Hello! Welcome to this Persistent Memory and Computational Storage Virtual Summit hosted by SNIA. My name is Jerome Gaysse. I am Senior Technology Analyst at Silinnov Consulting. It is still a great pleasure for me to share my knowledge and vision about new technologies such as computational storage during SNIA conferences. This year, it is a quite new way to talk about computational storage, with a focus on the benefit which is not well known in terms of X factor. I mean, the carbon footprint reduction. I am convinced that new system architecture, such as CS, are a great opportunity to limit the environmental impact in the digital industry. So, in this talk, I will start with some definitions about the carbon footprint to make sure that you understand well what is a carbon footprint analysis. And then, I will explain how it is applied to a real computational storage benchmark. Computational storage, or CS. I am sure that you all know it very well. Just as a quick reminder to be sure you understand it. The main concept is to move computing resources closer to the storage. As a result, you drastically reduce the data movement. For example, a computational storage drive, or CSD, will process the data directly in the SSD controller, avoiding to move data from the SSD to the host RAM and CPU. The host CPU becomes just a kind of system orchestrator. On this picture, the main processing part is the green block, which is part of the SSD controller. That leads to multiple benefits, where the two most important are better performance and a lower power consumption. Better performance because you save time in the whole processing task. The SSD controller processes directly the data from the NAND flash. Lower power consumption. Moving data is not energy free. Moving data may represent a huge percentage of the total energy in a standard system. Regarding this lower power consumption, there are multiple other direct benefits behind it. The first one, which is obvious, is that you reduce the energy bill at the end of the month, which can be very expensive for data center suppliers. Another consequence is that you require a smaller electricity infrastructure, then a lower capex for the data center, or less space, which is critical for embedded systems, such as industrial and transportation applications. Regarding the environmental impact, taking into account just this lower power consumption is not enough to get the full picture. Of course, it is very important and we understand why. But a more global analysis is more relevant. I mean a system life cycle assessment. Carbon footprint, what is it? You all heard about it, with the ambitious but needed target to become carbon neutral in order to reduce the climate change. The carbon footprint is an estimation of the greenhouse gas emission for a given system during its full life cycle, from the manufacturing to the recycling. An international greenhouse gas protocol splitted the carbon footprint in different categories, which are called Scope 1, Scope 2, and Scope 3. The Scope 1 corresponds to the direct emissions. For example, carbon dioxide emitted by a thermal engine. This part may be quite small if we consider the IT infrastructure only. I mean, the server, storage, network, and the hosting data center, where here the Scope 1 part will come from the gas standby power as a diesel generator. On the other hand, if you consider all the people required to manage this infrastructure, and you take into account the travel trip and the commuting, then the Scope 1 part may be quite high. The Scope 2 is related to the power consumption of the overall infrastructure. It is quite easy to measure and calculate it. This is mainly the multiplication of the power usage, the PUE, and the emission factor. The power usage is the power consumption of the infrastructure itself. The PUE, or power usage efficiency, is the efficiency of the data center building, including the energy used for the inverters and cooling systems, typically a number between 1 and 2. And the emission factor is related to the energy mix. It is provided in kilogram of carbon dioxide equivalent per kilowatt hour. The Scope 3 is the most difficult part to estimate. It is also an indirect emission, like the Scope 2, related mainly to the manufacturing, transportation, and the recycling phases of the product life in the lifetime. The manufacturing part is the most important due to the high level of energy required by the semiconductor industry for the chip manufacturing process. The transportation corresponds to the journey between the fab plant and the usage location. Note that here, the Scope 1 of a supplier becomes the Scope 3 of the buyer. As a result, the carbon footprint is given as a number in ton or kilogram of carbon dioxide equivalent. In fact, carbon dioxide is not the only greenhouse gas. Other gases are also emitted, with different greenhouse impacts on the environment. So, in order to ease the calculation and the communication, the other gases are converted in an equivalency of carbon dioxide. After this introduction on the carbon footprint with few definitions, let's go to the question how to calculate it in the real life. For that, we need data sources and tools. But the real first question is which perimeter to select. As explained in the previous slide, and especially for the Scope 1, depending on the perimeter you select, the result will be very different. By the way, let's take what you think relevant for the system you want to analyze. But for sure, let's take the same perimeter if you compare different technology solutions, or if you do another analysis 1 year later to measure the evolution. Then you need tools to measure the power consumption and get data to calculate the Scope 2, the PUE and the emission factor. That must be provided by your data center supplier. For the Scope 3, 2 possibilities. First, if by chance your product supplier provides you with the carbon footprint datasheet, then that's okay. just reuse it. If not, which is the case most of the time, then let's estimate it through standard database or with a detailed model. In any case, another parameter needs to be defined with the scope 3. This is the product lifetime. The products in IT are used through services, and these related services become with an annual average carbon footprint. So for that, you add the scope 1, the scope 2, and you take this scope 3 divided by the product lifetime. So, once you have your input data, let's use a tool that will calculate the overall carbon footprint. On top of that, it's interesting to get a detailed analysis. Knowing that the carbon footprint of an infrastructure is 10 tons of carbon dioxide equivalent per year, that's good. This is what you want to get. But knowing what is the percentage for the CPU, the RAM, the disk, the data to transfer, and other detailed information, it's even better, so you're able to optimize your design. This is what we designed at Silinnov Consulting. A specific talk on that will be given at another SNIA conference, a virtual conference. This is the Storage Developer EMEA on June 14. I invite you to register if you want to know more. Let's come back to computational storage. If you want to estimate the carbon footprint benefit of CS, do not compare a CS drive with a standard SSD. It makes no sense. Set up 2 system environments or more that will run exactly the same workload. Standard solution and a solution with computational storage. Calculate the carbon footprint on both systems and let's compare. Here is an example of a real benchmark. And thank you very much to the NGD team for sharing this data. On this example, a database workload is running in a virtualized environment. NGD compared 2 systems, reaching the same application performance. A standard one, and of course, another one based on the CS drive from NGD. The existing solution is using 16 standard servers, all with 2 CPU, 512 GB of RAM. Their power consumption is 500 watts, and the lifetime is 5 years. The new solution, based on GD CS drives, is based on only 2 servers, with the same RAM and CPU configuration, but instead of using HDD, it is equipped with 15 32 TB CS drives in each server. It is easy to understand few benefits in terms of power consumption and space density. There is no doubt that offloading the workload into the controller of the CS drives allows to use less CPU and RAM on the host side. You may be familiar with such benchmark from computational storage suppliers. But what about the carbon footprint benefit? Just with this technical specification and data, the answer is not obvious. That's why I applied all the methodology presented in this talk to this benchmark. Then here is the result of our estimation of the carbon footprint benefit, covering the scope 2 and scope 3 of the system. We used 1.3 for the PUE, which is quite good, and the average value for the USA for the emission factor. Note that both PUE and emission factors can be optimized, especially with hyperscale data center suppliers using renewable energy. So, the carbon footprint is divided by 3.7 thanks to the use of computational storage, from 52 tons to 14 tons, assuming a product lifetime of 5 years. Let's now go in a more detailed analysis with the values corresponding to the Scope 2 and Scope 3. Regarding the Scope 2, as explained at the beginning of this talk, it is quite easy to estimate it since it is directly linked to the power consumption. And you see that the power is divided by 10, so the Scope 2 is also divided by 10. Thinking that the carbon footprint is divided by 10 is wrong. Let's now have a look at the Scope 3 to understand why. So, regarding the Scope 3, the results are very interesting. Even if computational storage consumes less servers, the carbon footprint of the Scope 3, based on our model, is higher. It is explained by the high number of non-flash chips used in the CS drive. And unfortunately, that requires higher energy to manufacture non-flash chip compared to HDD. But there are two great hopes on that, because I don't want that you keep in mind that non-flash is bad in terms of carbon footprint. The first one is on the carbon footprint model. We are just at the beginning of such analysis, and current models are not very accurate. And this is the case for all the devices. And this is even amplified for non-flash with its specific 3D design based on the multi-layer technology. So I think that I'm very conservative here and that the real Scope 3 is lower. The other hope is on the semiconductor companies. Like for the hyperscaler companies, they invest a lot in renewable energy for their manufacturing facilities. So, in the near future, we will see the Scope 3 data of our models that will come with less greenhouse gas emission. In conclusion, computational storage brings real carbon footprint benefits, which is not a surprise. But here we can quantify this reduction up to 4x in the example we reviewed. Let me insist that this benefit really depends on the use case and the related energy mix. There is a major change in the scope ratio. With the existing solution, 90% of the carbon footprint is on the Scope 2. So here, this is where we really see the benefit of computational storage in terms of power consumption reduction. For the solution based on computational storage, 65% of the carbon footprint is on the Scope 3. So now, the effort must be done on the Scope 3. And part of the job will be done by the semiconductor industry, thanks to the use of renewable energy. I was also talking about the importance of the perimeter to select when we do a carbon footprint analysis. Here, I would like to highlight that in the presented study, we are not covering 100% of the real parameters. I do not consider services, software, and also the space. Since computational storage solution takes less space, for sure, there is also a carbon footprint benefit for that. And finally, be careful. When we talk about carbon footprint, I would like to insist again that the carbon footprint data are very inaccurate at this time. This is really difficult for all the companies to get data, especially for the Scope 3. Thank you very much for watching this session and hope to talk to you soon about new technologies and the carbon footprint reduction. Goodbye!